Alright, Potty Peeps, today we are learning substitution method, but oh my goodness, we're going to have 3 equations and 3 variables. Oh my gosh, so much different. Not. Okay, so what we're going to do, is step 1, we're going to choose an equation to isolate one of the variables in. So I'm going to choose the easiest equation. I'm going to figure out what one of the variables is. Step number 2, once I know what that variable is, I'm going to plug in that equation into the other 2 equations and simplify my results. When I do this, I'm going to be able to isolate one of my variables in my new equation, and then once I have that, I can plug that result into another equation and solve. Right? So I'll be able to solve for one given variable. Now, once you have one given variable, we'll plug that solution back into the equation you found in step 3. So back into this one and solve. So now you should have a solution for 2 of your variables. Well then, now once you have 2 of them, then it's easy to find the third, right? Plug the variables into what we found in steps 5 and 6, and then we'll get our original one. Okay, we can always, on step 7, we can always plug the values back in into the original equations and make sure that it is true. So let's look at example number 1. This is a little worked example for us. We've got the equation, the system of equations 3x plus y plus 2z equals 11. X plus 2y minus z equals 2, and, so we have 3 equations here, x plus y plus z equals 6. So step number 1, we need to find one variable. Doesn't matter if it's x, doesn't matter if it's y, doesn't matter if it's z. Alright, now this looks like the easiest equation to work with, so I'm going to work with that one. I'm going to solve for z. So I'm just going to subtract x to that side, I'm going to subtract y to that side. So z is going to be 6 minus x minus y. So now once I have z, once I have a given variable, I can take that given variable and plug it into the new equation. Right? So I'm looking at equation number 1, 3x plus y plus 2z, but now I know what z is. Z is 6 minus x minus y. So I've got 3x plus y plus 2 times 6 minus x minus y equals 11. All I did was plug in z. Now I need to go ahead and simplify this. Right, so I need to go ahead and simplify this. So I would distribute here. So I've got 3x plus y plus 12 minus 2x minus 2y. Okay, now I can simplify this down like terms. 3x negative 2x is a positive x. I've got y. Sorry, this is equals 11, my fault. Okay, I've got y. I've got a negative 2y, so that's minus y. Minus y. Okay, equals, now let's move the 12 to the other side, so subtract 12 equals negative 1. Now I'm going to go to the second equation and I'm going to plug in z also. So what does z equal? Z is equal to 6 minus x minus y. So I've got x, second equation, plus 2y minus z. So z is minus 6 minus x minus y equals 2. Once again, we're going to simplify that equation. So we've got a minus sign here. We need to distribute the negative. So we've got x plus 2y minus 6 plus x plus y equals 2. Now again, combine like terms. X, that's a positive 2x. We've got 2y, y, that's a positive 3y. We're going to move the 6, so we're going to add 6 to both sides, and that equals 8. Alright, so my new system then, my new system, solve for x in the equation, So we get x equals y minus 1. So I'm going to solve for x here because I want to get another variable, right? I want to isolate for another variable. Okay, well this is my new system of equations right now. Well, which one's the easiest to work with? This one looks easy, right? Because all I do is one step, add y to that side, and I get x. So x is equal to y minus 1. Well, now, once I know what x is, I can take that and plug it back in. So 2 times y minus 1 plus 3 times y equals 8. So I substitute it in again. Simplify and solve, so I get y equals 2. Well, now that I know that y is equal to 2, so now I can take that sucker and plug it back in. So x equals y minus 1, but y is what? Y is 2. Sorry, here we go. Y is 2, so I can take that. X equals 2 minus 1. 2 minus 1 is 1. Alright, so then step number 6, we know that x is equal to 1. We know that y is equal to 2. And we know that z going back up here, is equal to, let's find it, right? So I'm just going to take my original equation. I go back up here, x plus y plus z equals 6. I know that x is 1, plus y is 2, plus z, what we're finding, is equal to 6. Well, 3 plus what is equal to 6? Obviously 3. So then step number 7, let's make sure we're right. So we can plug it back in. I've got 3 times 1. Okay, I'm looking at equation number 1. Substituting it back in, checking myself. 3 times 1 plus y, which is 2, plus 2 times z equals 11. So yes, 11 equals 11, so 1's true. Same thing with 2. So my solution is x is 1, y is 2, z is 3. I know, guys. Okay, it does take a while. All right, so let's flip our paper over. Let's look at example number 1 on the back. All right, so example number 1. Again, we want to isolate for a variable. We want to isolate for a variable. So if it's me, I'm going to choose this middle equation. That looks easiest to work with. So let's find z. What does z equal? We're going to divide by a -4 on both sides. So z equals -5. Perfect. All right, so now once I know what z is equal to, I'm going to take these two equations and I'm going to plug in z. All right, so I've got -2 times x plus 3 times y plus 5 times z, which again, z is a -5, is equal to -21. Now I'm going to reduce, okay, so I've got -2x plus 3 times y minus 25 equals -21. Trying to get that into an equation, so I'm going to add 25 to both sides, add 25 to both sides, so -2x plus 3y is equal to 4. All right? Now, let's look at this equation. 6x minus 3y equals 0. Now, I can solve for y, right? So I can subtract 6x on both sides. I get -3y equals -6x. So I'm going to divide by a -3. And I get that y equals 2. Because I know that, sorry. So again, y is equal to 2x. All right, so now take that puppy, substitute it in here. So I've got -2x plus 3 times y, which is 2x, is equal to 4. -2x plus 6x equals 4. So x equals 1. So now I know what x is. I know what z is. Let's take it, let's plug it back in. So I'm just going to choose this top equation. I've got -2 times x, 1, plus 3 times y. I don't know what y is. That's what we're looking for. Plus 5 times z, which is -5, is equal to -21. So -2 plus 3 times y minus 25 equals -21. Bada bing, bada boom. Y equals, so I'm going to combine these two. Got -27 plus 3y equals -21. We're going to add 27 to both sides. We get 3y equals 6. So then y equals 2. Now, once again, we're not sure if we're right. Okay, we can always plug them back in and check ourselves. All right, but I'm going to give you a hint. Coach Sapp is correct. All right, let's go to the. So we're looking here. Okay, again, I want to pick an equation to isolate a variable for. So I've got y minus z equals 2. It looks easy to work with. So I'm going to add z to both sides. I'm going to get y by itself. I get y equals z plus 2. Y equals z plus 2. So now I'm going to substitute that back into an equation. I'm going to choose that puppy right there. So I've got -2 times y, but y is z plus 2. Plus 2z equals 0. Distribute your z, so -2z minus 4, plus -4, minus 4, plus 2z equals 0. Oh my goodness, combine like terms. Those cancel out, so -4 equals 0. What the heck? That's not true. That's a false statement. So my variables cancel out. It's a false statement. My answer is no solution. So this is a special case here. special case here. All right, let's go back up to the right side. So here's my system. Okay, once again, I need to pick a variable to isolate for. All right, so it doesn't matter to me. I already have x equals here. So I'm going to choose that one. I'm going to plug it in. All right, so I'm going to substitute that puppy in right there. So I've got x equals negative 5y plus 4z plus 1 minus 2y plus 3z equals 1. Now we're going to combine like terms. So my y's, negative 7y, my z's, positive 7z equals 0, because I got to move the 1 over. So now we're there. Now I can look right here. I'm going to substitute that in right there. So I know that x is 2 times negative 5y plus 4z plus 1. So again, I'm substituting back in. So I've got 2 times x plus 3 times y minus z equals 2. Distribute your 2 to all three of those terms. You get negative 10y plus 8z plus 2 plus 3y minus 2 equals 2. Simplify, you get negative 7y plus 7z equals 0. Now, notice those are the same, right? So negative 7y plus 7z equals negative 7y, plus 7z. All right, so when I go to solve for y or solve for z, my variables cancel out. 7z equals 7z. So 0 equals 0. That's a true statement. If it's a true statement, there is all real numbers. Or I could say infinite many solutions. All right, last one. Again, pick a variable to isolate for. Okay, so I'm going to look at this one right here. I'm going to solve for z. So I'm going to move the x, move the 5y. So I've got negative x minus 5y plus z equals 17. So I get z equals x plus y plus 1. 7. Sorry, this is positive 5y. So z equals x. I move the x. I move the positive 5y plus 17. Now, once I know what z is equal to, I can plug it back in. So let's say I plug it back into this one. Negative 5x minus 5y plus 5 times z, which is x plus 5y plus 17 equals 5. So negative 5x minus 5y plus 5x plus 25y plus 85 equals 5. Now we're going to combine like terms. My like terms are the 5x and the 5x. Those go away. We've got a positive 25 and a negative 5. That gives me a positive 20y. We're going to subtract 85 on both sides. So we get 20y equals negative 80. So then y equals negative 4. Alright, now I know what y is. I know what z is. Right, so I can take that. I'm going to plug it back into this bottom one. So I've got 2 times x plus 5 times y, which is a negative 4, minus 3 times z, which is x plus 5y plus 17 equals negative 10. Now let's solve. Right, so 5 times y, but I know what y is. Coach Sapp, come on now. 5 times negative 4. Okay, so I'm right there. All right, so 2x minus 20. Okay, 5 times a negative 4 is a negative 20. So I've got distribute here, negative 3x. Distribute here, we get a positive 60. And distribute here, we get a negative 51, 3 times 17. That's equal to negative 10. Now we're going to combine like terms. Negative x, positive 60 minus 51 is a positive 9. And then minus 20 is a negative 11. So x minus 11 equals negative 10. Now we're going to add 11 to both sides. So negative x equals positive 1, so x equals negative 1. So now we know that x equals negative 1. We know that y equals negative 4. Let's take that, plug it back into the original equation, and figure out what z is. Okay, or I could take that, plug that puppy back in there. So z is equal to x, negative 1, plus 5 times y, plus 17. So z is equal to negative 1 minus 20 plus 17. So negative 21 plus 17, z is equal to negative 12.